Hey, what are you doing here? I said not to click. Yeah, JDK 26 is entering rampdown phase 1 today and the feature set is frozen, but it's just HTTP3, better G1 performance and a new IoT feature. Oh, and new command line facts about reflection and updated previews of structural concurrency and stable values, sorry, lazy constants and... well, okay, I guess I can finish this later. Jeez.
Welcome everyone to the Inside Java Newscast, where we cover recent developments in the OpenJDK community. I'm Nikolai Parlock, Java developer advocate at Oracle, and today we're going to check out all the new features, removals, and updated previews in Java 26. Ready? Then let's dive right in. Starting with JDK 26, Java's HTTP client supports HTTP 3. At the API level, this addition is tiny. You can now pass the new HTTP client.version_enum value HTTP3 to the builder method version when building an HTTP client or request. You then go on to use the build instances as you normally would, and almost everything else happens beneath the surface. But unlike HTTP 1 and 2, 3 is based on UDP instead of TCP, which means you cannot easily upgrade an existing connection. Consequently, there is no obvious version for the initial connection, which makes it a bit tricky for the API to determine what HTTP version to use. JDK Enhancement Proposal 517 explains the process in detail, so give that a read to understand its trade-offs and how to configure it. In videos like this one, where I summarize all changes in a new Java release, I do my best to present each topic succinctly, so we're not here for 40 minutes, but with enough details that you get an idea of what's going on. Only some changes seem purpose-built to eliminate that middle ground, and this is one of them. Here's the short version. JDK Enhancement Proposal 522 improves the throughput of Java's default garbage collector G1 by reducing contention and synchronization over an essential data structure called card table. This leads to performance gains of anywhere between a few and up to 15%, depending on how heavily the application modifies object reference fields. The more detailed version needs to explain some garbage collection basics, how the regional garbage collector works, what a card table and write barriers are, and how the just-in-time compiler is involved, and all that before even getting to JEP 522.
Ain't nobody got time for that.
Exactly. I mean, if you do, check out Inside Java Newscast number 99, but everybody else, let's move on to the next feature. As of JDK 26, Project Guidance ahead of time cache does not contain any instances of your classes. But it does contain instances of JDK classes, most prominently of class for classes that were loaded and linked during the training run, and of anything referenced such as strings and arrays. So far, these instances were stored in a GC-specific format that allowed using the cache together with serial GC, parallel GC, and G1, but notably not ZGC. For compatible GCs, the cached objects were mapped directly into memory, which is really fast if the cache file was in the file system cache. To make AOT caching compatible with ZGC, JEP 516 introduces a GC-agnostic format for cached objects. Now, this cannot simply be memory mapped. Instead, objects are streamed into memory by a background thread, so GC can lay them out according to its rules. This requires some CPU time, but allows the startup process to continue, which can actually make the startup faster than memory mapping a cache file that's not in the file system cache. So besides GC compatibility, there's also performance trade-offs here. You can select GC-specific versus agnostic format with -XX : plus or minus AOT streamable objects. And the JEP also describes a heuristic for what format is chosen when, and I strongly recommend to give it a read if you're interested in improving startup time. And that's it for final features. Yeah, 3. I told you not to click. Let's move on to removals and then previews.
It is kind of amusing to note that Java managed to succeed despite having gotten almost all the defaults wrong, right? That references are nullable by default, that fields are mutable by default, that the default visibility is not private.
Yes,
that classes are extensible by default, right? So we got all the defaults wrong. And yet still somehow Java was a successful language and people still want to program in it.
That was Brian Getz in a conversation I had with him for Java's 25th birthday in 2020. There's a link to that segment in the description. The gist of what Brian was saying is that Java's initial design was shaped by influences and ideas that were en vogue at the time, but as times changed, quite a few of those didn't age well. But while it's easy to look back at them from the present and consider them mistakes, That's a myopic perspective. Quite a few of those mistakes were integral parts of Java's early success, and without them, there might well be no Java around today. One of those successful mistakes was serialization, but we're not talking about that today. Another were Java applets, little Java programs that you would download alongside HTML in bytecode form that the Java browser plugin would run on a local runtime and that could interact with the rest of the page. Basically the JavaScript of the late 90s. By the way, in a cosmic coincidence, JavaScript turns 30 today. Welcome to the old people club, JS. As JavaScript won out, browsers dropped support for powerful plugins like applets, and so they became essentially unused. JDK 9 deprecated them, and now, a mere 9 years later, JDK 26 removes them. It will be the first Java SE release without the java.applet package. If you're one of the unlucky few to still be using it, or are interested in a bit of Java history, check out JEP 504 and Phil Race's recent article on insight.java. Oh, and JavaScript? Applets didn't quite make it to their 31st birthday. Just saying in case you want to start putting your things in order. Another almost original sin that Java is working on fixing is the non-finality of the keyword final. In a future release, reflective mutation of final fields will fail unless explicitly allowed with the command line option enable final field mutation. Now, in JDK 26, it's still possible, but you'll get a warning. That behavior can be managed with a temporary option illegal final field mutation. Allow lets you mutate final fields. So does warn, which is the default on 26, but you'll get one warning per mutating module. Debug is like warn, but for every mutation and with more details. And finally, deny simulates the future where such mutation leads to an exception. For more details, check out JEP 500 or the last Inside Java Newscast. And if you're maintaining a codebase that mutates final field through reflection and are wondering what your alternatives are, keep an eye on Inside.java. I'm currently in the middle of writing a detailed guide for that specific scenario. Primitive patterns allow us to check whether a primitive value can be losslessly represented by a different primitive type. For example, can a given long L be an instance of int? Yes, if it's in the range from -2 to the power of 31 to 2 to the power of 31 minus 1. Can the same long be represented by a double or even a float? Now it gets more complicated. But thanks to primitive patterns, all of those are simple checks, whether with instance off or in a switch, for example, when deconstructing records. Then you can ask whether that JSON number node, for example, contains a number that fits into an int. JEP 530 previews primitive patterns for the 4th time, trying to get the edge cases just right that are bound to pop up with something tricky like an 8x8 conversion matrix between types, plus the ability to match on specific values. As an example for what changed in JDK 26, consider switching over a byte and having a label case short s followed by case 42. Since 42 can be expressed as a short, if the variable is indeed 42, case short s will apply. The label dominates case 42, which is effectively unreachable. JDK 26 assumes a dead label like this is a mistake and won't compile. If you want to learn more about the details, like type-based unconditional exactness, give the JEP a read. A common way to exchange keys or certificates, particularly when a squishy human is involved, is to use the text-based PEM format. The JDK comes with all the building blocks to turn these texts into cryptographic objects and vice versa, but that required a decent amount of custom code. Starting in JDK 25, Java previewed an API that makes these transformations much easier. First, you create a PEM encoder, then call encode with an instance of the new interface DER encodable, which types like asymmetric key and X509 certificate extend. And then you can store or send the resulting byte, array, or string. On the other end, a PEM decoder instance can decode from a string or input stream and return a DER encodable instance that you can pattern match over. Alternatively, you can specify what exact type you expect and then either get that back or an exception. You can also encrypt these objects and configure an alternative cryptographic provider. In JDK 26, JEP 524 previews the API for a second time with a few changes, most notably the added support for key pair and PKCS8 encoded key spec. Another API that sees its second preview in JDK 26 are stable values. Or rather, lazy constants, because while the API's core functionality to provide exactly once lazy initialization with great runtime performance remains, its surface sees major changes all the way to its name. So much moved around that I'll dedicate another newscast to it either in 2 weeks or next year. Subscribe if you don't want to miss it. If you can't wait that long, check out JEP 526. After the Structure Concurrency API saw a big revamp in JDK 25, 26 is refining that new version and sending it out for another preview with a few small changes, most of them to the joiner interface. It can now implement on timeout and thus do some cleanup and define what exceptions should be thrown in that case. All successful or throw now returns a list of results rather than a stream of subtasks, and any successful result or throw dropped result from its name, and it's now just any successful or throw. As with all preview language features and APIs, if you want them sooner rather than later, the best way to get them to finalize is to try them out in as close to a production environment as you can and give feedback on the respective mailing list with what worked well for you and what didn't. And that's it for today on the Inside Java Newscast. Have fun with Java 26, and I'll see you again at... Yeah?
Haven't you forgotten something?
No.
But the vector API...
No, I've not forgotten it. I intentionally skipped it.
But shouldn't you explain to
No,
your audience
no, we're not
why-
doing this.
No! Out! Out!